This is the solution video for section 4.3, problem number 2. It says use the graph of f prime to determine the intervals for which f is increasing and decreasing. Give the values of x for which f has local extreme values. All right, so remember, it's important to note that this graph is f prime. That is what we are told. All right, so remember, what do we want to determine? Well, we want to determine the critical numbers on this interval, right? Now, remember, local extreme values cannot occur at endpoints, right? So endpoints are here and here. I haven't even labeled the numbers because we don't even want to give those as values. All right, but when is f prime equal to 0? All right, so when is f prime equal to 0? Remember, this is a graph of f prime, so really, wherever this graph crosses the x-axis, right? That is when it's equal to 0. When is this graph undefined? Well, it's never undefined, right? On this interval, right? There's no like open circle, asymptotes, anything like that, right? So our critical numbers, right, are going to be x equals -3, 0.5, 2, and 4, right? All right, now, what do we know about local extreme values, right? All right. So we know that a local extreme, okay, a local maximum occurs when the derivative changes from positive to negative, and a local minimum occurs when the derivative changes from negative to positive, right? Now remember, whenever the graph is negative, it is decreasing. Whenever it is positive, it is increasing. Remember, whenever f prime is negative, the original graph f would be decreasing or increasing. All right. So when is this graph when is f increasing? All right, so f is increasing when f prime, remember, f prime is greater than 0. So remember, this graph is f prime. So whenever this graph is greater than 0, meaning above the x-axis. So anywhere that it's above the x-axis. So right there, so that would be from -3 to 0.5, right? And then right here from 2 to 4. All right, when is this graph, or when is f decreasing? Well, remember, decreasing means when f prime is less than 0. So whenever this graph is below the x-axis, right? So there. So now, if this is an endpoint or an arrow or whatever, I think on the answer sheet I have an arrow. So we would say negative infinity until -3. And then right there in this section, so 0.5 to 2. And then over here from 4 to infinity. All right. So that is increasing, decreasing. Now, where is a local maximum? All right, a local max, remember, occurs when the derivative changes from positive to negative. So it changes from positive to negative right here at 0.5. Sorry, local max at x equals 0.5. Does it change from positive to negative anywhere else? Yes, right there at 4. All right. What about local minimum? Remember, a local minimum is when the derivative changes from negative to positive. So below the x-axis to above the x-axis. So at x equals -3, and then also here at 2. All right. And so that